Hello everyone, let me introduce myself. My name is KETUT ASRI Laksmi Dewi. You may call me Laksmi. I'm from class 4D and my last ID number is 07 and 6. Thank you for being here in my video, and my presentation is about topic 11, which is the concept and application of vector. In this session, I will explain what a vector is, how we write it, and what types of vector exist, how we operate with vectors, and where we use vector in real life. And I will also use some important English vocabulary related to this topic. So please pay attention, and because these words are often found in mathematics texts, let's begin. Before I explain the definition, I want to ask you a simple question first. Imagine a pilot is flying an airplane. Is it enough for the pilot to know only the speed of the plane? For example, if the pilot only knows the plane is moving at 500 kilometers per hour, can the pilot reach the correct destination? Please think about it for a moment. The answer is no. It's because the pilot also need to know the direction, north, south, east, or west. This simple idea, speed plus direction, is actually the foundation of what we call a vector. That is exactly what we are going to learn today. Now let's talk about the definition. A vector is a quantity that has two important parts: magnitude, which means the size or amount, and direction, which means where is it going. This makes a vector different from a scalar. A scalar only has magnitude without any direction. For example, 20 kilometers, 5 kilograms, or 30 degrees Celsius. Meanwhile, a vector always includes direction, such as 20 kilometers to the north or 5 newtons downward. In a diagram, we usually draw a vector as an arrow. The length of the arrow represents the magnitude, and the arrowhead shows the direction. The starting point of the arrow is called the origin or the tail, and the ending point is called the terminal point or the head. Now, let's learn how to write a vector correctly. Look at this. There are several common notation. First, we can write it as a bold letter, such as V or A. Second, when we writing by hand, we usually add a small row like this above the letter like this. And third, we can also write a vector in component from, and which means the vector is broken down into its x part and y part. And the fourth, to find the size of a vector, we use the magnitude formula. The square root of v of y x squared plus y and y units along the x-axis and 4 units along the y-axis. If we calculate the magnitude, we get the square root of 3 squared plus 4 squared, which equals the square root of 25 or simply 5. Please remember these important vocabulary words: magnitude and direction, component, origin, terminal point, axis, and others. And next, let's move to the different types of vector. There are 5 types that you must know. The first is the equal vector, which has the same magnitude and the same direction as another vector. The second is opposite vector, which has the same magnitude but points in the opposite direction. The third is unit vector, which is a vector with a magnitude of exactly 1. And the fourth is the position vector, which always start from the origin point 0, 0. And the last is a zero vector, which has no magnitude and no direction at all. Understanding these 5 types will help us to recognize vector more easily in different mathematical problems. And after knowing what a vector is and its types, let's discuss what we can do with vector. In other words, vector operation, there are 3 basic operations. The first is addition, written as A plus B, and to add 2 vectors, we use the tip to tail rule. We place the tail of the second vector exactly at the head of the first vector, and then we draw a new vector called the resultant vector. From the very beginning to very end, the second operation is subtraction, written as A minus B, which we can solve by adding vector A to the opposite of vector B. And the third operation is scalar multiplication, written as K times A. This operation can make a vector longer or shorter, and if the scalar number is negative, it can even flip the direction of the vector. Now, let's talk about why this topic is important. Where do we actually use a vector in real life? First, in aviation and navigation, pilots and ship captains combine speed and direction, which we call velocity vectors, to reach their destination safely. Second is physical and engineering. Important quantities such as force, velocity, and acceleration are all vector, and engineering use them to design safe buildings, bridges, and machines. And third, in computer graphic and video games, vectors are used to move character, camera, and objects smoothly across the screen. And fourth, in GPS and robotics, vector helps a device calculate position and movement accurately. So, can you think of another example from your own daily life where a vector might be hiding? Let's practice reading a mathematical problem written in English. Here is the text: a ship sails at 40 km per hour due S, while a current passes at 10 km per hour to the north. Find the ship's resultant velocity. Let's solve this together, step by step. First, we treat the two speeds as two vectors that are perpendicular to each other: 40 km per hour to the S and 10 km per hour to the north. Second, we calculate the magnitude using the same formula as before: the square root of 40 square plus 10 square, which gives us approximately km/h. Third, we find the direction using the inverse tangent function of 10 divided by 40, which gives us approximately 14 degrees north of east. Please notice the important vocabulary in this problem: resultant, perpendicular, duas, and angle of direction. Now, let's summarize what we have learned today. Number 1, a vector has magnitude and direction, unlike a scalar. Number 2, vectors can be written as a row component from x, y, or with magnitude bars. Number 3, 5 K-types equal opposite, unit, position, and zero vector. Number 4, vector can be added, subtract, and multiplied by a scalar. Number 5, vector power navigation, physics, engineering, and computer graphics. And yeah, thank you for your attention. Thank you very much for your attention throughout this presentation. Before I close, I would like to leave you with one more question to think about. Can you find one more example in your daily life where a vector is hiding? Please feel free to share your thoughts, and I'm very happy to answer any question you may have. Thank you so much and have a great day.